Welcome back to the channel. In this video, we are going to see how to configure a DHCP server on a Ubuntu VM and test it in the EVE-NG environment. In this setup, our Ubuntu VM acts as a DHCP server and the DHCP clients are Cisco router and TinyCore Linux PC connected through a switch. We'll go step by step and configure the Ubuntu server and verify that both the DHCP client devices are receiving IP addresses automatically. We'll start by updating our Ubuntu DHCP server to make sure all the core packages are current and reliable. On the Ubuntu terminal, run sudo apt update and sudo apt upgrade -y. Now I will install SSH so I can log into my Ubuntu VM from my PC. This will help me to copy, paste and edit the configuration files wherever needed in this video. Now we will install the DHCP server package on Ubuntu. On the Ubuntu terminal, type sudo apt install isc-dhcp-server-y. This command will download and install the DHCP server software. Once the installation is complete, we can move on to configuring the DHCP settings. From my PC using SSH, I am using SSH to copy and paste the configurations which is hard in Ubuntu VM inside EVE-NG. Now I am inside the SSH terminal. Now we will configure the DHCP server. First, we edit the main DHCP configuration file. On the terminal, type sudo nano /etc/dhcp/dhcpd.conf. Here we can define the network settings and IP ranges for our lab devices. When you open the DHCP configuration file, when you scroll down, you will see some default lines like option definitions common to all supported networks, default lease time 600, maximum lease time 7200. Our subnet block will go after these lines. You can also add your subnet block by finding an existing subnet line, uncomment it, and then edit the IP range and settings inside the curly brackets. This is another way to define the DHCP scope for your lab devices. Now we will add our subnet scope below the lease time line. I already have the scope prepared in Notepad. It includes my preferred subnet range, default router, and DNS server details. Next, I will copy and paste it into the terminal. For this lab, I am using the 10.10.10.0/24 network. The DHCP range is from 10.10.10.51 to 10.10.10.150. The default router is 10.10.10.1 and the DNS server uses Google's addresses. After editing, press Ctrl X to exit, then press Y to confirm. Finally, hit enter to save and close the editor. Next, we set the interface for the DHCP services. So we note down the network interface name using IPA. Our interface is ENS3. Now open the file with sudo nano /etc/default/isc-dhcp-server. Then set the line. Scroll down Then set the line interfaces v4. Inside the code, double quote, type ENS3. This tells the DHCP server which network interface to listen on. Now press Ctrl X to save this file. Now we restart the DHCP server to apply the changes. On the terminal, type sudo systemctl restart isc-dhcp-server. Next, enable the service to start automatically on boot. Type sudo systemctl enable isc-dhcp-server. Finally, check the status to make sure it's running. Use sudo systemctl status isc-dhcp-server. Here current status is active failed. The server status failed. This is because the server does not have a fixed IP yet. Without a static IP, the DHCP service cannot start properly. Now we will assign a static IP to our Ubuntu VM. This makes sure the DHCP server always uses the same IP address. Now I will open the network configuration file using sudo nano /etc/netplan /filename 01-static-ip.yaml. You can choose any name you prefer. I'll edit the configuration in Notepad first. Now I copy paste the configuration into the editor. In this lab, I am assigning the IP address 10.10.10.2 to the ENS3 interface. Once the changes are made, we'll save the file and apply the new settings. Now we apply the network changes using the command sudo netplan apply. This updates the system with the new static IP configuration. Now my SSH session has ended because the network restarted. So I'll go back to the Ubuntu VM terminal. Now I check the status of the DHCP service again, and the status is still showing as failed. So I'll restart the DHCP service using sudo systemctl restart isc-dhcp-server. Then I check the status again to make sure it is running. Type sudo systemctl status isc-dhcp-server. Now the DHCP server is active and running. Now we will look at our network topology. The Ubuntu VM is currently connected to a cloud link for internet access. I'll shut down the VM and connect it to the existing LAN network in our lab. After that, I'll power the Ubuntu server back on. In this setup, we are using a Cisco router and Tiny Core Linux as DHCP clients. We will power on both of these devices. The server and the clients are all connected through a switch. Now we will open the terminals of all the devices except the switch. In the router terminal, I'll now configure the interface IP address to be assigned by DHCP. After configuring, we can confirm the address by using the command show IP interface brief. This will display the interface details and show if the router has received the IP from the DHCP server. Now we can check the DHCP logs using the command sudo tail-f/var/log/syslog. Before hitting enter, we will power on the switch so that the router and Tiny Core Linux can receive an IP address from the DHCP server. Once we run the syslog command, the output shows the DHCP process like discover, offer, request and ACK messages. Here we can see from the output that the DHCP server has issued IP addresses to two client devices. The addresses are 10.10.10.51 and 10.10.10.52. These addresses are from the DHCP scope that we configured earlier. Now we will go to the router console. Here we can see from the syslog messages that the router has received its IP address 10.10.10.52. Next, we will move to the TinyCore PC terminal. We will run the command IPA. The output shows the TinyCore has received the IP address 10.10.10.51. Now we will check basic connectivity between the devices. First, from the router, I will ping the Ubuntu server IP address. The ping is successful. Next, from the Ubuntu terminal, I will ping both the router and the TinyCore PC IP addresses. These pings also succeed. This confirms that all the devices are reachable and communicating properly. That's it for this lab. We successfully configured a DHCP server on Ubuntu and assigned IP addresses to a router and TinyCore PC and verified connectivity between all the devices. Thanks for watching and don't forget to like and subscribe for more tutorials.